Let's talk now about discrete random variables. So a random variable is discrete if it can only take a finite or at most a countably infinite number of values. So it takes values which are countable. So all possible integers, for example, is countable. The integers between 0 and 5 is also countable. So that's the most common example of a discrete random variable when we're actually counting the number of times some event happens. So the probability mass function of a discrete random variable we write as little p of x, or sometimes little f of x, and it's the probability that the random variable is equal to the value little x. Now the PMF is another way to characterize the random variable x as well as the CDF. It's got a one-to-one relationship with the CDF. If you know the PMF or the CDF, you can find out anything you want to about a random variable. You know, if we knew the PMF for every variable out there, you know, most of the world's problems would be solved, to be honest. But often we don't. But we can often deduce some things about the PMF of a variable that we might measure. Okay, so for example, one thing you could calculate is the probability of any event. So probability that x is in some set A, you just sum the PMF values for all x's within the set A. Something a PMF will always do, it'll always sum to 1. If you sum it over all possible values in the domain of variation of x, you get 1. Okay? So if you graph a PMF, it's going to be spikes. Okay? It's these points along where you get a probability mass and particular values on the x-axis. And if you look at the CDF function, that has steps in it. It's a step function which jumps up anytime you've got a spike, anytime you observe a value of x. So some examples of discrete random variables. The simplest example is the Bernoulli random variable. That is a discrete variable that takes just 2 values. Let's call those values 0 and 1. There is some probability pi of getting 1. So the PMF is equal to pi when x is 1, and it's equal to 1 minus pi when x is 0. For some value pi between 0 and 1. When I'm writing pi there, I'm not talking about the value in a circle. Okay, so don't think about the 3.14 thing from circles. I'm just using pi to represent a parameter of the value from the Bernoulli distribution for the probability of getting a 1. The reason I'm using pi is because when we're talking about random variables with some unknown value, some parameter in them, we commonly use Greek letters for it. And so I'm using the Greek letter pi because that's Greek for p for probability. So Bernoulli variables are really common, they're really important, they're used to characterize any event that has 2 possible outcomes. So occurrence or non-occurrence of something, presence or absence of something. Other examples of discrete random variables beyond the Bernoulli, we've got number of anything, really. Number of scratches on a surface, number of defects amongst 1,000 objects that are tested, number of earthquakes in Australia over the last year, in a given year. The sum of the number of points like that you get when you roll 2 dice. Anything that involves a count is going to be a discrete variable.